All right. So thank you everyone for joining. Thanks, Dipin, Danina, Sudesh, Harsh, Sayan, Ankit, Arnav, Pratim, Pallavi, uh, and then Adityan is also here. Hi, Deepto. Hi, Kunal. Few folks are still joining. So what we're gonna do is uh, we can do it two ways, right? Like we can either start with your doubts, or I can quickly give you an like a quick, let's say, rundown of the videos for uh, week one, because that is probably where hopefully most of you are. But yeah, looks like not really. So I see Ankit is midway through week one, and Devaya, somebody is also midway in week one. So, and then Sayan also. So good one. So yeah, I think, and then okay, Adish has finished, but these are, I think, students from earlier. But yeah, Danina's also, oh, Danina's finished week one. That's great. And okay, couple is from earlier. Then there are Pranav. Okay, good one. Pranav is also all right. And then some folks from earlier. So yeah, so I mean, so I mean, I'll just show you what I was looking at on my side, right? So we've built a dashboard where we get to see like what meetings you attend, uh, where you are in your journey, and we get to see, if you've completed your circle profile, and this was all done by our internal team members, including Vishal, Yashanki, and so on. So Aditya has also not done all these internal members. I think we need to kind of look into. Amina, if you're here, like let's like ping them, understand what's going on. If
Yes,
internal members are not up to date, then I think there's a bigger red flag for me, right?
yes,
So this is, yeah, like our backend, and for example, if you click on someone, it'll show like today's maybe our first meeting. It'll show like their messages also here, but of course on the phone, and then here we see like what. So everything is green because it just started. So this is just for us to kind of understand where you guys are. Like, of course, we cannot do any policing. It's a self-paced course, but we do have complete visibility on, where we are in our journey, how much effort we're putting in, like how badly we want it essentially. So what I want to do is like quickly brush over the topic that we want, which we have covered in week one, which is the simplest, and very quickly, right? So it's 8:04. We'll finish before 8:20, 8:25, max 8:30, and then half an hour for like going deeper into it, asking your questions. And especially people who've done week one and are already midway week two, like Danina, feel free to ask or add or give comments and suggestions. I think it'll be useful for everyone. All right, so I'll quickly share my screen and I'll go to the slides that we use to generate the videos, right? The ones that we used in the videos. So we started by saying like, why data-driven algorithms? Why can we not like write hand-coded programs for everything? Why did we resort to, let's say, machine learning? But even before we get to machine learning, we spoke about basic statistics, right? So there is this handwritten digit one, and we want to write a program to, let's say, recognize this. Then there is handwritten digit two, and we want to write a program to recognize it. And we quickly see that it becomes very difficult. Maybe for one, you still write a hand-coded program, but for two, I mean, you'll have to fit curves, etc., which becomes very difficult. So we say, okay, what if we just take a simple average of all these, let's say, 10 different tools written by 10 different people? And that is the first statistic of the distribution, right? That's just the mean. And even the mean would be probably a better algorithm. Like if you use the mean, you can write a better algorithm to decide if this is a handwritten digit two or not, just by comparing with this template that you get by, doing this per pixel averaging of your handwritten digits. So this is already like a good data-driven model, but of course, this doesn't have any learnable parameters. It doesn't even have the second moment, which is the standard deviation, right? So it's just the mean. So it's probably the dumbest way you can do data-driven, but it's still way more powerful than what you can come up with, let's say, by writing this hand-coded program. Then we make the case, okay, why, okay, ones and twos are still okay, but then when you go to like cats and dogs and humans, I mean, it becomes very, very difficult, and their hand-coded rules are really not possible. And in a data-driven paradigm, what we do, we have this train and predict functions. In the train, we give it all the parameters and their corresponding labels. What are images and like data points and labels? Like images, let's say, are our uh, data points. So you can have multiple images, multiple data points, each of them. So this is supervised. Each of them have a class associated with it. In this case, it's cat, dog, and mug for these images. And this function returns a model, right? And then we use this model in the predict function. In the predict function, we send in the model and the images that we want to classify, and we send the output, right? We send the result of the model over these test images. And this is how we kind of go into data-driven side of things. Then we spoke about the simplest, I mean, let's say the after the mean, maybe nearest neighbor is again a very simple algorithm where we, let's say, compare with everything in our data set. You can do slightly better. Instead of doing a linear search, you can maybe do KD trees, you can kind of divide, and but again, in high dimensions, KD tree doesn't work very well, and the performance is not really like much better, right? So nearest neighbor is like has some, let's say, uh, advantages, but in reality, not everyone would use nearest neighbor. But there is a very interesting example from Spotify, and I don't want to spoil it for you, but maybe if you've already seen it and you want to share it with someone, you're welcome to do it here. Otherwise, I would recommend you look at that when you do the videos. And it's in, the rabbit hole section of our videos. Then we talk about hyperparameters. Hyperparameters are essentially these knobs with which we can kind of decide, change the behavior of our model. So in nearest neighbor, we have this parameter k. How many nearest neighbors do you want? And this is kind of this one knob that we have based on which we can change the behavior of our nearest neighbor algorithm. And the answer is like, how do you choose the best value? It is very problem dependent, and you need to kind of test out a bunch before you know what works best. And for this, we have this so-called eval set, right? And eval set is where we kind of find our hyperparameters. You have to be careful because if you look at your eval set too many times, what happens is you're then overfitting your hyperparameters to your eval set. This is very deep. Think about it. But like even if you don't see your training data, even if there is no data leakage, I mean, then at least your weights are, let's say, pure, but your hyperparameters are not pure, right? If you kind of overfit it to your test data. So for that reason, we use our test data very, very sparingly because this is I mean, we want to use it for generalization performance. And what you can instead do is do this k-fold validation where you divide, let's say, your training data into 5 folds. And now you train it on fold 1 to 4 and then test it on 5. Then you train it on, let's say, fold 1, 2, 3, and 5 and test it on 4. And based on this, you tune your hyperparameters. And once you've tuned your hyperparameters, only then you run it on your test data very, very sparingly. Right? So this is your validation data, and we call it cross validation. And then this is where things get interesting. So, I mean, before I proceed, like any questions so far? No, I mean, I'm gonna ask you questions in a bit. So if you don't have questions, I mean, that's cool. So then, I mean, this is where things get really interesting, right? Because now we're like, okay, we have learnable parameters. And what we're saying is, okay, we want to, like, we have a function, and our function is very simple right now. It's a linear function. We're just multiplying. So X is your image. So this is your image. It's size 32 cross 32 cross 3. We essentially flatten it into one big vector. So what is the size of that vector? It's 3072. And this is this X vector, which is of size 3072 cross 1, right? So it's a column vector. And then we want to multiply it by this W. And this W would be of size 10 cross 3072, because we want 10 classes as output. And we want to learn the values of W. W starts off as a random, randomly initialized matrix. But these are the weights. This is what we want to learn. What we want to learn based on data is if we multiply our data with W, will it give me the correct class? Yeah, so what we want is the output 10 cross 1. Our weight matrix is size 10 cross 3072. Our input, which is this image, is of size 3072 cross 1. And there is this bias, you can ignore the bias, but bias essentially is always of the size of the output. And in this case, our output is of size 10 cross 1. So our bias is also of size 10 cross 1. And now, I mean, you can interpret the in linear classifier. If you visualize the weights, you see something, but because it's so simple, right? And if you do visualize, so what we have done here is so what happens is, you take your column and it gets multiplied with the rows of your matrix W, right? The rows of the matrix W have the same size as your data, 3072, which is 32 cross 32 cross 3. So now if we visualize the rows after training, we don't know how we have trained, but assume like we will learn this in the next week, how to train. But after training, the weights look something like this. And this is truly interesting because what are the weights? The weights are essentially trying to maximize the probability of us landing in the correct class, meaning us getting the right highest value in the right class of those 10, right? So here you have this 10, and of these 10, we want, let's say, the third class to be high, right? So what will it take? What kind of row should I have in W, which will lead to the highest output? Because remember, we are doing dot product, and dot product essentially is high when it looks exactly the same, right? And when it's orthogonal, when it looks very different, then it's minimal. Dot product, if we're doing between, let's say, unit vectors, so you can always normalize them. And if you have unit vectors both in the rows of W and the columns of your Xi, then you just have the cos between the two, the cosine between the two vectors. So what is interesting is maybe horse, right? So it looks like a two-headed horse because in the data set, the horses are on, facing both the sides. So now if I get a horse facing either side, and when I multiply with these rows, obviously this one will get me the highest output. So the third last component of the vector, of the output vector, will be highest when the input image is a horse, right? So this is how your learned classifier will look like if we have learned how to train it. Then we talk about the forward function, how this forward is happening. So in this case, we have three training examples and three classes. So these are the three training examples belonging to, these three images, and these are the three classes. And initially, you get some wrong scores, right? So for example, here you get a wrong score. You get a high, this should be highest. Similarly, here this should be highest. Luckily, you got the right score even with the random weights. But here you got the really wrong score, right? You got the worst score possible because here this should have been the highest. So we kind of want to express our happiness with the scores. We want to say we are really happy with this because you got it right. We are kind of unhappy with this because you got it slightly wrong, but we're really unhappy with this, right? So how do you kind of mathematically formulate that? And we do that, it's very simple. What we do is we first exponentiate it, meaning we put it on e to the power. So e to the power 3.2 is 24.5. E to the power 5.1 is 164. E to the power minus 1.7 is 0.18. Why are we exponentiating it? Because we want to kind of exaggerate it, right? We want to make it peakier. So we want to kind of like exponentiate it, right? We want to stretch it. We want to make it more drastic. So we did that, but then we want to normalize it so that it's easy for us to, do those vector multiplications, etc., that we were talking about, or put it inside log, etc. So and because we want like a probability output, because we want it to sum to one. So what we do is we got these unnormalized log probabilities. They're also called logits. And then, so we normalize it. How do we normalize it? We divide 24 by the sum of 24 plus 164 plus 0.18, and that is equal to 0.13. If you were to mathematically write this as a formula, you would essentially say, okay, minus yi log of e to the power si upon sum of all e to the power sj's, right? These are e to the power sj. In this case, this is these are, sorry, e to the power sj's, right? So you sum them up and you put this in the denominator. And yi is your one hot vector. In this case, only here it is one, and for these two classes, it's zero, right? Because we're looking at the cat image right now. So the sum, I mean, so the final loss, so this is the Li, and the final loss is essentially the sum of all the Li's, right? So, but all the other Li's will be zero because there is a multiplication of zero because Yi is zero. So let's just focus on this one, right? This Li, L of the correct class, where I in this case, when I is one here. And so for that, this is the score. So now we get a negative log of that, right? So negative log of 0.13 is 0.89. So this is the loss. The loss is not very high because we got it right, but we didn't get perfect. Like ideally, I would want it to be, sorry, so we didn't get it perfectly right. So we got a loss. If we got it perfectly right, if we got a one, then we get zero loss because log of one is equal to zero. So the goal here is to get less loss when you have a correct. So for this one, for example, we would get, when yi is equal to 1, we will get a lower loss, right? Because negative log of this would be, let's say, lower. So this is what we learn, in the one, and then we talk a little bit about weight regularization. Uh, I would like you to kind of look at the video, and then we talk about gradient descent, meaning we started with W somewhere, uh, and now we want to find the best values of W. The best values of W would reduce my loss function, which reduce my unhappiness. In this case, we do it with just two W parameters, just to kind of visualize it, because we can visualize 3D by projecting onto 2D, which is our screen. And this is the loss, right? So here we see that, okay, even if we started from here, we want to kind of find our way to here, and which we do through these iterative updates to the weight, right? And for this, we do the gradient and the Jacobian, and we talk about this in week 2. But essentially, optimization is how we get good values for W. So there are ways to do this using numerical gradient, where we just, perturb it a little bit, and but that would be slow. So finite element methods. And then for most functions, when it's, like continuous and differentiable, we are able to get the analytical gradient, and which is exact, fast. But I mean, we say error prone. This is just while we want to build it, because the first time it's hard, but then once you have it, and of course in PyTorch, they're all correct. And then we kind of do this iteratively and find the best values for W. We also do it in batches, in these so-called mini batches, especially when doing deep learning. And yeah, we talk about this in the lectures as well. And then we go into like backprop. So backprop, I'm gonna cover like next week, and I would recommend you first cover the lectures, the videos. So then when we talk here and discuss, it'll kind of be easier and more meaningful. So that's like in 15 minutes, exactly, because we started at 8:04. Like a brief overview. Also, first week the content is less. Maybe the next weeks we might need a little bit of more time. And this was like a very quick monologue to kind of refresh your memory of what you may have seen in the videos. And if you haven't, please see. And also, especially before my session next week, if you are able to see videos of week 2, I think it'll make a world of difference to your journey. So yeah, so now all of you, like I would love for us to kind of discuss, talk about things that you already have done, or most importantly, doubts.
Orchin, Pratim here. Can you
Okay.
be more specific about the dimension of the vectors, and also why we are flattening the vector, flattening the image? I could not understand it.
Yeah, that's a good
So,
question. Like, why flatten the image? So we want to flatten the image because we want to represent it as a point in a high dimensional space, right? Because it's a point. Because if you don't flatten it, what will it be? It will be a matrix, but matrix doesn't make a sense in data, like if you want to treat it as a data point. Matrix is an operator to this vector. The matrix can do things to this vector, right? This point in the high dimensional space. That is why every time we have a data point, we have to flatten it into 2D, because that is the, so we will also talk about like vector spaces, we'll talk about latent spaces, we will learn how to represent your higher dimensional image input into this low dimensional vector. So this is why we convert an image into a vector, because we have to, because that is the only way your machine learning algorithm will be able to understand or do something with that image in the form of a vector. Does, and like the sizes, I mean, you have to kind of do it yourself. You have to do the assignment. Have you seen my videos, by the way, yet, Pratham?
Yeah. I have seen. Yes,
Okay.
yes.
So
That's why
then, like,
I had this doubt. That's why I'm asking.
no, so okay. So then let me show you again. So, all right. So, yeah. So, I mean, I want to ask you, right? Like, what is the size of X?
That is the input image actually. That is 32 plus 32 plus 3.
Yeah, but now we have converted into a vector because we want it as a point in a higher
Yeah,
dimension.
3072 plus 1.
Yeah, that is a, like, that is a decision you made, that you want to represent it as a column vector. You could also have done a row vector, but column
Okay.
vector, I mean, is just a standard, right? So if you do a column vector, then you know that, you know, your output will also be a column vector, and output is of size 10 cross 1. Why? Pratham, what do you
Because
think?
there are 10 different classes, right?
Exactly. Yeah. So now if we have the output as 10 cross 1 and our input is 3072 cross 1, we have no other option, right? Because W, then the size is already predefined,
Okay.
right? Like you don't have any wiggle room.
Okay. Okay.
What is the size of the matrix when you multiply it with the 3072 cross 1 and you get as output 10 cross 1? You have no other option.
Okay.
Does that answer your question?
Yeah. That answers my question. And another question is about the training set actually. Like for example, can you go back to the next point maybe? You were showing 10 different classes, right? Of 10 different objects here.
This one?
So
Yeah.
these are the 10 objects, right? And
Mm-hmm.
for each of these objects in the matrix, in the corresponding element, we will get
Mm-hmm.
a particular weight value, right? As an outcome of this. And my question is that one, like we will be getting it for suppose individual images, and when we say about training, right? So how with how many images do we generally train, and any kind of
Yeah, so all
practical
this we
example
will
can you give?
cover, yeah, later. But in this case, we have again no option because we are using this CFAR data set. So CFAR data set has a set amount of images for training and set for testing. 50,000 for training, 10,000 for testing.
Okay. So this is as per the simple data set.
Yeah, so this is based on this data set. But usually, you know, like, there can be some rules of thumb. I mean, it depends on how much data you have. Like, there is no hard and fast science, like something that you can derive from a formula of how many training images. So all these are just best practices and, you know, like more of an art than a science kind of a thing. Like how many data points do you need? Depends on the complexity, depends on the number of classes, depends on the dimensionality of data. But there is no formula how many data points are enough.
Okay.
So the
And
best thing to do it is to kind of take your problem and then map it to, let's say, a problem that exists in literature. And most of, like, very often it doesn't exist, right? So you have to map it to the closest problem that exists in literature, see how, usually in literature it'll be like a cleaner problem, then you can kind of extrapolate and estimate how many images would probably be a good start for, let's say, your algorithm, for your training. Yeah, sorry, you were saying?
yeah, I got your point actually regarding this
Okay.
training set. Uh, okay. And well, suppose we are writing a program for this, so probably we'll start with a random number only, right?
Yeah.
In place
So
of
we
the
do it as homework. So yeah, like you will see that we do the whole thing.
okay.
So as soon as you do your assignment, I think you'll also connect some more dots that you have in your mind right now. But yeah, good. I like your questions. It shows that you have gone through the content, you have thought about it. So that's great. So
Thanks.
next, yeah, who wants to go next?
Yeah, I have a question. I mean, maybe a silly one. So,
Yes, no,
so the
Ankit, there are no silly
302,
questions.
like
Yeah, go on.
the 3072, does it represent the pixel? Basically, the matrix will have the pixels, and if we take all the numbers from the matrix and just convert it into a vector, is it a is it that simple, or is it some more
Yeah, yeah,
transformation
it's
within
that
that?
simple. Like the matrix
Uh,
currently, it is 32 cross 32 because this side it has 32 pixels, this side it has 32 pixels, and then there are three channels of RGB.
Correct.
Right? So what we have done is we have essentially taken all of that and flattened it into this one long vector. Of course, it has lost spatial relationships after that, right? But anyways, this is dense. Like in W, you don't need those spatial relationships. So it is as simple as that. You've just multiplied 32 into 32 into 3, taken all these pixel values, right? These intensity values across these three channels for every pixel and put them in a vector. That's it.
Okay,
And
and we
how you
often
put them in a vector also doesn't matter as long as you put it consistently in the same way for all the data points.
okay, we often hear a word called embeddings or vectorization.
Yep.
Is like more or less same thing, or it is
No,
a
so
more
here it is not an embedding yet. It is just
okay,
a dumb, let's say, representation of data. But now, if we are able to reduce it from 3072 to maybe 300 or 100, then it becomes an embedding where you then throw out most of it. Because, for example, you don't need like a lot of numbers. Like, look at this background. There is no information here, right? So, can you compress that? Can you remove that and only keep the important things in there? So that is the embedding, right? That is also called sometimes, the latent representation, the embedding, the activations even. So we talk about all of that starting from week 3 and then week 4, where we get into like self-supervised methods, how to learn those embeddings, etc.
okay. And in the very next slide, so basically we are trying to classify 10. I mean, we we are
Yep.
we are trying to find out 10 objects, basically 10 different kind of objects. So
Yep.
for each object, you are saying 10 images, right? I mean, that's what at
No,
least the picture says. Okay, it can
no,
be any
no,
number
not at
of
all.
images.
This is one
Okay,
image only.
okay,
So this is only one image, right? This
right.
3072 here is only one image. I multiply it with a matrix of size 10 cross 3072. It gives me one vector of size 10 cross 1. And that one vector will have, I want the third. So which one is cat here? So you see cat. So if I got it correct, then the fourth number in that vector will have a high value and the rest of them will have a low value. And that is how you know that okay, we have to whatever, I mean, the output corresponds. So you then do an argmax, and then argmax will give you the index 4 if you got it right. So I want the fourth value in that vector of size 10 to be highest if I have trained it well, if this is actually working.
Okay. Okay. So
Yeah.
the number of images which is being used to generate this superimposed image
Hmm.
doesn't matter. It remains 10 cross 3072 only.
No, no. 10, where is 10? So 10, 10 cross 3072 is not the image. It is the size of this matrix W.
The
This
weight
is
matrix.
the
The
weight
weight.
matrix.
Yeah.
Yeah. But I have not spoken about the number of images. The number of images can be many. They can
Okay.
be 5,000. Here, I'm not talking about training as much yet, right? So when we talk about training, then we basically do these iterative updates. We do this many, many times. So we do this using many, many images, maybe 50,000 images.
Okay.
So we do these updates 50,000 times or something like that. But this image is all about a single image. It is not about multi images.
Got it.
Awesome.
Understood.
Great. Great question, Ankit.
Again, I have one question since
Yeah, Anish, go on.
you mentioned that when we are flattening, we are losing some information about the relative position of those pixels.
Mm-hmm. Mm-hmm.
I understand while training, the W will capture that information or learn from that, and it will resolve it. But is there any way that since we already know the relative position, will it help to like train faster or something like that? Will that work?
Yeah. So we will talk about it again like week 3, week 4 when we talk about CNNs, convolutional neural networks. What we are doing here is this so-called fully connected, meaning we are connecting all the pixels to each other. So here it doesn't matter because it doesn't matter where it is positioned. But in reality, what may happen is not every pixel might affect every other pixel. So like you said, it's not very efficient, and there are ways to maybe make it efficient and with have lesser number of trainable parameters and so on. And we'll talk about all this in when we talk about CNNs.
Okay. But isn't in just a like linear regression way, will it like is there any way to do that, or only CNN
No,
is the
no,
way?
linear regression, there's no way to, because you don't need to do that, right? Because linear regression, it is doing a fully connected. It is connecting
Oh,
every pixel to every other
okay.
pixel using a weight. So there is no need to put that spatial relationship. It can automatically learn if it finds out that it doesn't have a relationship, it can learn zero weights for all those things. But it's just
Okay.
inefficient.
Okay. Understood.
Yeah.
And in the graph that you showed about the gradient descent thing, mm,
Mm-hmm.
like there are like local minima in the graph itself has like
Yeah, that's
kind
a
of
good question. Yeah, go
two
on.
two
Mm-hmm.
dark blue areas.
Mm-hmm.
Like, is there any like some sort of thumb rule or something that we know like we are stuck in the which local
Yeah,
area
that's a
or
great
something?
question. I'm very happy that you asked this question. So, I mean, before I go to the TAs, I want to talk to the students, right? Like, uh, Denina, what do you think? What he said is, now you started from here. Where will this go to? Right? Like, will it go here or will it go here? And where should it get to? Is it like a good idea if it goes there, or that's not a good idea? Like, what if this is a better minima? So, what do you think about these questions? Anyone? Yeah, go on. Okay, TAs maybe?
It will really depend.
Harsh, Dipen, I saw this as well. Yeah, go on.
I
Okay,
can take a crack at it, right?
go on. Sorry, Siddesh, yeah?
Yeah, I was just saying. So like lambda is a hyperparameter, which is essentially like the distance with which we are moving from the current position where we are, right?
Yeah.
And because you're moving at a very gradual pace in the right direction,
Mm-hmm.
you'll eventually going to end up at the closest local minima. And is that the best solution and not like let's say a actual minima? I think we settle for that and it works fine for us. Is my current understanding? Although I'm not sure
Yeah, that's the
if
perfect
that's
answer. So what Siddesh said was, yeah, like it depends on the size on the step. If you're taking really large steps, then you might be able to bounce around. You might from here maybe able to cover this minima, come here, etc. Right? And then, but here it looks like the step is slow, like low. So you would end up in the nearest local minima. And there are papers where they have kind of claimed or given some analysis on things like are all spawn equal. So there is like, but again, they put a lot of, let's say, constraints when they study these kind of local minimas. And what they found was like somewhere, yeah, that I mean, these local minimas are sort of equal, right? All, if you have a good, under certain conditions, these local minimas are equal. And in that is what you kind of roll with, that you don't have, let's say, so what you can do is you can start with different initializations. And if you start, and that is why you do like ensemble methods, because then you have the possibility of reaching, like if you started with a different initialization from here, then you would end up in this local minima. But usually, uh, local minimas are born equal, and that is the assumption that we roll with. So, yeah, perfect answer. Does that answer your question? Who was
Yeah,
asking?
but I understood. But is there any way to know that we are like stuck in local minima, or like do we need to like start with different position? Like, if there's no
No,
way,
so
or
yeah,
how is it like?
there is no stuck in local minima. Either your method converged and you're in a minima and you're happy, or your training did not work.
I mean, can you get a better W that is actually giving better result, right? I mean, it's
The
working,
only
but
thing you can do is
with
try with a different weight initialization, and in general, it will not help much. So yeah, like there's not too much you can do about not being in that local minima.
No, but is there a way to find like there is a global minima or
No, there is no way.
okay, so we don't know like what is the actual global or optimal minima.
Yeah, you don't know. You can never know.
Is there any boundary condition that we can say, like this is the minimum?
No,
Should
that
go?
welcome to deep learning. So deep learning is very empirical, and because it's such a complex function, composite of so many functions, you cannot really have these error bounds, the boundary conditions, some tight bounds, etc., on these kind of methods. Especially when you relax these assumptions and when you're in the real world with real data. Yeah, I know it's very like dissatisfying, but I think you kind of get over it and learn to live with it and move on and just look at the power of what it has rather than, the nice properties that linear regression has, but deep learning doesn't have. So obviously for linear regression, you can do all of that, but not for when it's like a very complex, and you can still do that when you do it under certain conditions with a lot of, aggressive assumptions, but you cannot do it for like the relaxed and general case mathematically.
So then it will hold true for the local minima also. Like we also don't know like what is the local minima.
No, because you've converged. Because now it doesn't improve there because the learning rate, I mean, because it's a flat region. So when you
Yeah.
do your dou y by dou x, you're getting a very small gradient. You're almost getting zero because it's flat. So that means you're at a local minima or a saddle point.
Okay.
And if you're at a saddle point, so saddle point is like another flat area like here, right? So if you're here, then you will get bad training. You will not get good results on your test set. Then you would try different things. You'd maybe change your initialization, and then hopefully you'll get a decent minimum.
Okay. Okay. And so it holds true for the saddle point also then.
Absolutely.
Okay.
Yep.
Sir, I have a question.
Just to add, sorry. So now there are like second order methods, right? So if you had a second order method, then you would know if it's a saddle point. But the problem is like when you compute the Hessian of 1 billion parameters, 2 billion parameters becomes, like I think 1,000 trillion or something like that. So you cannot fit it in memory. It's not possible to do it for real world models. Yeah, sorry, go on.
Yeah, can you elaborate what is like second degree like?
So like when you compute not just dou y by dou x, but dou 2y by dou x square. So then you not just know
Okay.
the gradient, the slope, but also the curvature.
Okay, got it. Thank you.
But again, you cannot do that because you need like a Hessian matrix to do that. So which is of size, number of parameters, cross number of parameters. So, if you cross billion into billion, so 10 to the power 9 into 10 to the power 9 is like a really huge number. Yeah, but all great questions. So keep them coming. But like there's a huge distance. I mean, everything is that you want is on the other side of finishing, your weekly content. And I know it's a difficult task, but I would recommend to kind of first finish it and then go back to it as many times as you want. But finishing should be your goal if you really want to succeed in this, because this is just the beginning and it becomes really, way more. I mean, the learning curve becomes steeper, and that is, I mean, an honest, let's say, realization. Because for me it's really easy because I've done it so many times, but then when I see it through the lens of students in the last 4 cohorts, there is a big, let's say, percentage who are not able to finish the course because they get stuck on like on these small things in the questions that you have. So sometimes it's better to still kind of continue even if you are stuck with these questions. Attend your TA sessions, attend these sessions, ask those questions, but finish the course regardless, even if you have to use an LLM, even if you have to use coding agents, etc. And if you start accumulating debt in terms of time spent on this course, then it becomes like really, really difficult. So people who have joined us from the last cohort, maybe you would want to share some warning. Adish, I think you joined from the last one.
Yes. Yeah, I
Yeah, you
think.
want to maybe share some experience so that people here can benefit from your learnings from the past.
Yeah, I think to be honest, 8 to 10 hours per week is actually enough. So, and the only thing I think from the other people which I have heard that week two is somewhat difficult. So it's fine if you had to rewatch 2 or 3 times the week two, and once you go through week two, then it's fine. So
Yeah, week two is definitely also, in my opinion, the most interesting because you actually build a PyTorch clone. Of course, a very simple one to do very minimal things, but you see how modular it can be. You look at the software in, engineering side of things. You get a lot of confidence because you do things from first principles, from scratch. So I think you're gonna enjoy it. But yes, anything worth doing is never easy, and this is why week two, like you very rightly said, can be a little bit, let's say, steep. And you're welcome to watch the videos multiple times.
sir, I have a question. Maybe
Yeah,
I'm
please
just
call me
assuming.
Arjun. Yeah, Adish, go on.
Okay. So maybe just I just want to know if my assumption is correct or not. Like
Mm-hmm.
though in normal mathematics, like in quadratic equations or cubic equations, we can differentiate it, and then we can at least find that okay, it has at least these number of minimas. Okay, you can like in quadratic equation.
Yeah.
So we could have done that same with this. The only thing is that it is really expensive. That's why we don't do it, right?
Yeah, I mean, with polynomials, it's algebraic geometry, right? Like you don't know how many zeros of that polynomial exist, how many of them are real, etc. So there is algebraic geometry, Grobner bases, ideals, rings of polynomials. So that's a different thing. So I don't think we want to relate that to here. But yeah, at least you could do second order here numerically, but you cannot because of practical constraints, because of GPU compute memory.
Okay. So my assumption is correct, right?
Yes, that is
Okay.
true.
Okay.
Great. Anybody else? Danina, you wanna add something?
Nothing for now, but I think when I was doing, I had a lot of questions, and since there was Claude, I kept asking, and at the end, it was done with me with the questions I was asking. But yeah, but I think by next week, I'll have more questions that I'll write it down because I cannot recall. But yeah, I mean, honestly speaking, there's more questions that rise from each video, and through that questions, I'm learning more basically. So it's
Yeah, like
pretty
try to, yeah, like not hand wave it to yourself. That I think I understood. Like try to ask questions as if you were then, having to explain in this session. Uh,
exactly, yeah.
yeah. So I think that could be like a good strategy. Kunal, what about you? Like,
So I have started the course and I've finished off the first two lessons and the quizzes. So
mm-hmm.
yeah, that's the progress, and I'll be
Yeah, I
covering
can see you're at 30%. So yeah, good work.
yeah, I'll be covering in next 2 days, the first week.
Okay. So in the first two videos that you watched, like, do you have any questions, any thoughts, anything that you want to share with us? Kunal? Why?
Um, yeah, like I got pretty much everything, so nothing to ask like specifically. Uh, yeah, but I'll ask in the next session.
Nice. Yeah, perfect. What about you, Aditya? Aditya Yadav? Aditya,
Hi,
you're.
Arjun. Actually,
Yeah.
I'm traveling, so the voice is a bit break.
But no problem. But I see that you haven't started your videos yet, right?
Yeah, I haven't but I will start in a bit.
Yeah, do that. Like, otherwise, like we already kind of, you should have finished ideally your week one by today. So the next week when we meet, please finish week two by then. Otherwise, you'll fall behind.
Yeah, so I've already watched it on YouTube, but I haven't completed on the circle.
Okay. All right. Yeah, so then do that. But then it'll be easy for you to just do the question answers directly then.
Sure, sure.
Cool. What about everyone else? Harini, Pranav, Deepto.
No,
Yeah.
so I didn't know that yeah, I have to finish these two courses like before this class.
Okay, no worries.
Yeah, okay.
Yeah. I mean, you have until Monday, but yeah, if you finish it by today, then we can have a much richer, better discussion, right?
Okay, okay. I'm still getting used to the circle because I couldn't find yeah. Even I missed the last class because I couldn't get the meeting link. So
Oh, and that's not on your calendar?
it didn't appear. Then I found like it was in spam or so.
Got it. Got it. Got it. So, Amina, can we maybe like do a circle session for people who are interested, like people who might have like questions about circle, just like a quick one,
Sure, we can do that.
right? Like just to walk them through various places in circle. Can you do it now? Like quickly open up circle, just show them different spaces,
Yeah, sure,
what they need to look at, what theirs would look like when they open up.
sure.
Yeah, while she's opening it up, like anybody else?
So, Arjun, one question regarding
Mm-hmm.
the classes. So, this is week one, right? So,
Yes.
in the next session, next time when we meet, the next week, next
Mm-hmm.
Tuesday, the expectation would be to finish week one along with the
No, the
assignment, right?
expectation
That
would
would be
be
the
to
expectation.
finish week one in terms of like the videos, the assignment and everything, but also finish week two videos, right? So if you finish week two videos by Tuesday, then it is guaranteed that you will do very well.
Okay.
Yeah.
That is the
So then after
video.
that, you can spend time on finishing your assignment, etc. after that.
And also the basic question regarding
Mm-hmm.
the AI assisted coding. So, will we get some kind of
Yes.
free licenses
Yes.
like for
Yes, yes,
WinShop
yes.
or something like that?
Yes, you'll get a lot of things. You'll get Claude code, you'll get Denina, sorry, Amina, what all will they get? They'll get Claude, they'll get GPT, they will also get Windsurf, right?
Run pod.
No, Runpod is for later. Runpod is when you like GPUs for their capstone,
One
etc.
second.
But you'll get ChatGPT Pro, you'll get Claude, and you'll get credits in Windsurf.
So from this week onwards, we'll get this.
No, so this is after week one. So week one, we want you to code
Offer.
by hand. It's like really 1 or 2 lines of code that you have to write. And then people
Okay.
who then like stick around, like because after week one, if you wanna leave, right, you can leave. And then people who stick around, we're gonna give the accounts to them.
Right. Thanks.
Thanks, Pratham. Pranav says you joined last cohort and completed week one. It was good content and quizzes were good. Will revise. Sounds good, Pranav. But yeah, I mean, instead of revising it, you already did week one, right? Like move on, like just do the assignment and move on to week two. I think just complete it. Trust me, the value in completing it is like immense, and completing it is hard. Like completing anything is hard, in my opinion. Like, you have to have the discipline, the grit, the perseverance to go through it and like do it. So people who I put on the spot were like all fast code people. Rest, everyone here is a TA, so I don't need to put them on the spot. Navrat is the only TA who doesn't have the video today, but that's okay. What about you guys? Like, who all did I not call out? Like Ankit, I think you haven't spoken, and then Harini, Chandra.
Yeah, so I also completed the first few lessons. I haven't finished the later part, but yeah, I'm looking forward to finishing that and then getting to the assignment. Hopefully, I'll have some questions for the next
Yeah,
session.
yeah, but that's great, and I see that you're doing very interesting work in RL, etc. So we're only gonna touch RL like towards the end when we use it for RLHF loop when we do fine tuning of our LLMs. But yeah, really interesting work that you're doing, and all the best. And yeah, I hope that we can together learn some interesting things here as well.
yeah, looking forward to seeing what else I can, implement using my research work. Yeah.
Cool. Awesome.
Yeah, I've just like started with the week one lessons, but yeah, like maybe like next week, like I'll just try to complete. I'll maybe like at least the videos of week two, so I can have a few questions to like post here and just learn from it.
Yeah, it'll just register more. I mean, if you kind of are there by then. Even then, I mean, even if you've not completed the videos, it'll still be okay. But if you've completed, then I think it helps you more. And another thing I noticed is we don't have like a LinkedIn and GitHub for some of us, right? So, I mean, like maybe you can get some of the developers to give you a list and then ping them so that we can have like a more complete community. So, for example, for Chandraya, we don't have his LinkedIn, etc. So, people who are willing to share the LinkedIn, some may have forgotten. Let's reach out to them once more and complete their profiles. Just give me a second, one second.
Amina, I think there's a few questions in the chat. If you can maybe answer that for them.
I actually had by mistake something happened and Zoom turned off, so I'm not able to see the messages.
Okay, okay. I can read it out to you. So, Deepto has asked, he has joined, and there was a class before this. And where can I access the class recordings?
It's there in Circle. I've added you in the Circle,
But,
Deepu.
Amina, can you share your screen and show where it is?
Yeah, something happened. I mean, like the whole browser
No
turned
worries.
off. So
Can
I'm
somebody
just.
else who's logged into Circle, can you share your screen? If you've not logged in, can you just quickly log in? So we'll show. It'll be easier for you to understand, Deepto. And then, okay, I can now read out the questions. Yeah. So, Deepto, we answered. Pranav also said, yeah, we already. And then Sharat's question, Adityan already answered. So thanks, Adityan, for answering his question.
Arjun, I can share my screen.
Oh, perfect, Harsh. Amazing. Please do. Thank you.
Yeah. So like I was in cohort 4. So like this is the main Circle page. Here you can find the introduction part
No,
where you
now it
just
should be open for everyone, Harsh. So I think you also have access to cohort 5. Just click check. We've opened every cohort for everyone. Click on cohort 5.
Yes.
Yes. So this is the recording of the various. So we always post our recording here. Go on. So this was like my first session, right? Like, so this is the second one. That was just like the welcome cohort, we call it the first assembly. So this is a summary, including the video, and we always post this. And for the TA session, we have the videos and we can post it also. But yeah, it'll create too much noise, right? Because it's not for everyone. So we don't want to post it here in our complete cohort space. They call it space. So Deepto, does it make sense for you? Do you know where to go?
Yeah. Thanks for explaining this. Yeah, I basically joined today. I was watching the week zero videos on matrices and dot products. So
Right.
yeah, I'll complete that and I'll move on to week one and try to complete. I'll try to complete week two as well. Yeah, and yeah, thank you.
You're most welcome. I mean, the goal should be complete week one and complete week two videos, right? Week two videos means every video you also have to answer those questions which are there for every video. But if you do that by week, my next session next week, I can guarantee you like that you will be successful.
Deepto joined just today.
Okay, welcome. Good.
Thank you. Thank you.
Yeah. So this is like the questions that you will have. Don't show them the correct answer. Yeah. I'm just kidding. But yeah, good. So anything else, folks?
Arjun, so I
Yes.
have a question.
Yes, Kunal.
Yeah, in the first video, you mentioned the learned models encode the patterns in the fixed size parameters. And once
Mm-hmm.
they are trained, the prediction time depends only on the model's architecture, not on the size of the how much the training data is. So
Mm-hmm.
what it depends on the model architecture you mentioned. Then
Mm-hmm.
what are you referencing to the model's architecture?
Yeah, we talk about models architecture later when we talk about the history of deep learning. We talk about AlexNet, ResNet, InceptionNet. So hold on for model architecture. Currently, the model architecture is just linear regression or linear classification, where you just have a weight matrix and it's simple, just one layer. That's the architecture for now. Yeah, Sharad, go on.
Yeah, Arjun, you had said something about the test sample to be scarcely used.
Yeah.
And can you double click on it? Like,
Yeah, absolutely.
why? Yeah.
So, who wants to answer that? What we spoke about, the test set and why we should be careful with it, even if you're not leaking it into the training set. Any of the students?
You said something about generalization of the performance.
Yeah, so I mean, anybody wants to answer? If not, like the TAs, anyone?
Can I, Arjun?
Yes, please. Depend.
Yeah. So where you actually just focus on the training set, you sometimes overfit your model just to perform good on the training set. So let's say you do all sorts of optimization to get 99% on the training set, and sometimes when you apply it on a
No, that's
general
not the question, Depend.
data,
The
it might
question is,
perform
why
poor.
should you not test on your test set too many times?
I'm not aware of that.
Anybody knows the answer? Why should you not test on your test set too many times?
I guess then the model would be too biased towards the data in the test set and would not
Why?
perform
You
as
did not
well.
use it to learn. Then why is it biased?
Mm, right.
Siddesh, Harsh, any ideas?
Can I guess?
Yeah, please, please.
So ultimately, the in principle, test should be like a good enough reflection of what will happen in real life once the model is
Generalization.
out.
Yeah. Hmm.
So if you have a very rigid and predefined and static test, then you are doing injustice to the real world that it is supposed
No, no,
to.
no, no, no. The answer is very simple. What
Okay.
happens is we run it in the test set, right? We see it maybe did not do very well. We go, we tune some hyperparameters. We say, let's change the learning rate. Let's change the K for nearest neighbor. Let's change the architecture of the model. So we are changing the hyperparameters by looking at the test set. And because of that, you're overfitting your hyperparameters, not the weights, not the real learnable parameters, but you're overfitting the hyperparameters to your test set. Because by looking at the results of the test set, you said, oh, it doesn't work very well, let's tune it a little bit. So that is the risk you run by touching the test set too many times. So that is why it's sacred. If you want it to really like be a be a proxy for generalization performance, for real world performance, when you train a model and then throw it in the world. But great question. Does that answer your question, Sharu?
Yeah. So what you mean is that hyperparameter tuning should be done using that test and train fold combinations.
Yes, validation as we call them. Yeah, exactly. Yeah, great question. Cool. We had a great session, but this is like, yeah, really the easy part. And like, I want all of us to like pull up our socks. Otherwise, what will happen? We've seen it for four cohorts, like people start dropping off. They first start collecting debt and then they start dropping off and then they never finish. So I don't want it to happen to any of us. And, we were not doing this teaching business like last time. We were just starting with doubts, but I think this is something which will hopefully bring you to my future sessions and will also kind of set the stage better for asking these doubts. So all the best.
One
And
question.
yeah, Gulshan, go on.
One question, like after week one, could the remaining week lectures be like front loaded? If people want, like for my case, I think I have a 1 week gap where I'm traveling. So I was wondering if I could cover it up earlier.
Yeah, absolutely.
But
Go for it. Like cover all of it, the 8 weeks. Yeah, I mean, we want you to consume as much content as possible. So, like, as soon as you finish, we'll open it up, or even if you request for like 2 weeks in advance, we're happy to do that for you.
okay, thank you.
Yeah, all right. Yeah, good then. I'll see you guys next week. Really looking forward. Attend your TA session. They'll also teach some topic. Maybe you can ask them, other questions. And I really hope to see all of you and more next week. So all the best. Bye. Bye, everyone.
Thank you, Arjun.
Thank you.
Thank you.
Thank you, Arjun. Bye.
Bye-bye.